So welcome and welcome back to our channel here. This is the math channel, like my favorite GDC here. I got a request for students who like to know how do we use GDC with the differential calculus. So the first thing I would think of is finding the tangent and normal. So let me write down tangent and normal. Look down the list. Check. Tangent, normal, and also we will need to find the limit. So there's a few things we could do with it. So first, for example, if you need to find the limit of those, that is when the x asymptote will be found. So for example, we have fx equals to 3x minus 4 over 2x minus 1. So we need to know that a limit of those. So all you can do is, one of the way is you go to manual, you go to table, and you fill in the equation here. So we will have 3x minus 4 over 2x minus 1. So you will have the information there. They got the list there with the table. So all you need to do is just like doing a setting with it. So maybe you step from 0.5. Then you will know that it's still okay. So let's see, if I'm going to do that, I can start from 0. That should work here now. So when you get to 0.5, there is an error there, which means that when x equals to 0.5, that will be an error. That with the limit is we cannot have x equals to 0. Or further, to validate it, we can go to manual and go to graph to graph that out to see how this look like. Because I keyed it in the table, it's already here. So all you need to do is set the calculator correctly, and you can see that is the graph here. Haven't used this calculator for a long time, so if something gone wrong like this, always go back to check the manual and to see the grids. Let me find the grid line on, axis on. So once the axis is on, everything should come back to normal, and we can see that the x asymptote is x equals to 2. Here is one of them. So let me mark that off. And for tangent and normal, we always should question always ask you to find the equation of the tangent and normal at a certain point. If you got that at a certain point, it's easy to do it. If it's not, then you have to do your differentiation by yourself. So fx, say for example, fx equals to 3x squared minus 4x plus 2. See if this looks nice here. So we will have 3x squared minus 4x plus 2. Come on. Okay, that's a pretty lovely quadratic there. So we could do this here, and then we need to find the equation at the tangent and normal with those. Normally, if you do it by hand, you have to differentiate it, and then you substitute whatever in it when x equals to 2. So you substitute that in, find out the gradient, and then find the equation of the line. You can find this in the other video, but then this is more like to be the calculating bit. So to do this with our calculator, we will have to, first of all, key in the equation here we need. That is the original fx. Then before you do anything, make sure you go to setup, which is shift menu. Make sure the derivative is on. Now it's off. We need to turn it back on there. Otherwise, there's nothing to be seen. Looks like nothing happened, so we go to sketch. Now we want the tangent, so equation at the tangent. So first of all, we need to key in whatever it is. So you can move around to find out what you need, or just press 2. Once you press 2, you give out the dy dx, which is the gradient, and the y-intercept is 6. So when x equals to 2, y will be equal to 6, and dy dx, which is the gradient, is 8. All you need to do is press exe one more time. The equation of the tangent will show, which is y equals to 8x minus 10. This only works for GDC paper. If it's non-GDC, you skip all those steps. That doesn't really work here. All right, similarly with the equation of normal, you do the same thing. So we go to sketch. normal, say for example, this one is y equals to x equals to -2. Then you got the gradient here, the equation there. The only problem is they give you in a decimal place. So if they're going to picking on you, they can make you like, I like to have the exact value, then that might be an issue there. Or they want to have the rational number or in fraction. That would be a bit of pain to make you do some work there. All right. Last but not least is the turning point. Sorry, I missed that out here. Turning point. I'm sure some of us will know that already. Let me add another degree to it. So now give it a curve. So it's always finding the turning point, which is even easier, would be just like G soft, you find the maximum. This is the turning point here. And when we have the minimum, and then you go to G soft minimum, that is the other turning. So between the maximum and minimum, it is decreasing. That's how we find that out. And anything before the maximum and after the minimum, that will be increasing. That's how we mainly use our GDC for the differential calculus. You know who you are. I hope that helps. And let's see how it goes. Thank you.